Blood. If you're sick and you need it, nothing else will do. The tricky bit is, there's only one way of getting hold of blood, taking it out of people. People like me. Around 4,000 litres of blood are used in hospitals all over England every day. It's vital for life-saving treatments, and that's why donations are so important.
I'm just about to insert a needle into your arm, Xand.
Yeah, so that's in, and actually it really didn't hurt at all. You feel a bit of a scratch, and it's not a very nice idea, but Linda's a real expert, so it's completely fine.
And you're doing really well there, all up and going.
There it is, filling up. Now, your body is actually a blood factory. It's constantly making new blood, but it makes it in a place you might not expect, in the middle of your bones. In fact, our bodies can produce 2 million red blood cells every second. That's incredible. I'm donating about half a litre of blood, the equivalent of almost 2 cans of fizzy drink. That's around 13% of the blood circulating around my body. Now, you can't give blood until you're 17, but you can receive it, and it could save your life. That's me done, and it only took 5 minutes.
It's going to come out now, OK, well done. Just keep pressure on there for us, OK, that's lovely.
Thank you very much.
It's been a pleasure.
This is a bag of my blood, and sometime in the next 35 days, it's going to be put inside someone else, possibly saving their life. But it can't go straight into them. First, it's got to go to the blood factory. This is the largest blood factory in the world, and we're going in. I've never seen anything like this. Behind me are 800 bags of live human blood. Wow! And John Kirkwood is here to tell me what's going to happen to my blood.
Your blood will be one of 3,000 donations that we'll have taken from donors.
So we're talking about a small swimming pool full of blood every day coming in here.
Yes.
All the blood coming into the factory first gets put onto a giant rack where it's filtered to remove some of the cells which can't be used by every patient. What happens next?
Well, then we take the pack round to what we call a manufacturing pod, and then we will take out the plasma and the platelets and the red cells.
The factory's job is to process and sort our blood into 3 main products which treat patients with different medical needs. The first product is red blood cells, which are often used for operations and transfusions. Then there are plasma and platelets. The darker liquid, plasma, contains proteins and cells to help patients fight diseases. Finally, platelets are tiny but important. They help blood clot and can be used for specialist bone marrow and cancer treatments. To split up the red blood cells from the plasma and platelets, the blood is put into here. It acts just like a big washing machine and spins around really fast, causing different cells to separate into 3 layers. Then a big press squeezes out the plasma and platelets, so you end up with them in bags up here and the red blood cells at the bottom. In a different part of the factory, a vital step in the processing is taking place: testing. Every unit of blood that's donated has to be tested for 2 reasons. First, blood can carry diseases, and you really don't want to catch a disease from a blood transfusion. The second reason your blood needs to be tested is that just like people have different colour eyes or different colour hair, people actually have different kinds of blood. This is called blood groups, and you may have heard of them. There's A, there's B, there's AB, there's O. Now, if you get given the wrong kind of blood, this could be fatal, but don't worry, these guys are very good at what they do. These are the final products of this massive blood factory. Thousands of bags of living human blood, including mine, all going out to save lives. Because thousands of litres of blood are being used every day in the UK, it's vital that blood donations keep coming into the factory to be processed, ready to use in our hospitals.
Ouch. How much blood does an average adult heart pump around the body every day? Is it enough blood to fill approximately A, 100 teaspoons, B, 100 oil drums, or C, 100 Olympic swimming pools?
The answer is B, 100 oil drums. That's around 23,000 litres of blood.
Ouch. And now to our lab for some amazing body experiments.
Ugh! Whoa! Just don't try anything you see here at home.
Today, it's your body's ticker, the heart. Xand is having a little lie down.
You could actually try this bit at home. It's quite nice.
Or what you can't try at home is hooking Xand up to an electrocardiogram, which is what I've done.
It's basically a heart monitor. And each one of these spikes on the display is a separate beat of the heart. And it doesn't matter what you're doing. Even if you're just lazing around like Xand, your heart never stops beating. It beats even when you're asleep. As Xand seems to be illustrating perfectly. You can see the spikes and his pulse is around 70. OK, Xand, demonstration over.
What? What? What demonstration? I've been awake the whole time.
Now, your heart was beating when you were a 6-week-old embryo inside your mum, just the size of a raisin.
Your heart is made up of millions of tiny cells, and each one of those cells beats on its own.
And here's one of them. This is a single heart cell. It just won't stop beating, even without its mates.
Absolutely brilliant, isn't it, Xand? Xand? Xand!
What?
It's not nap time. Now, if you ask more of your body, say when you exercise...
Exercise?
Yes, Xand, exercise. Your heart will step up and help you out. Right, give me some nice big star jumps, please, Xand.
When you exercise, your muscles need lots more blood and oxygen. To provide this, the heart speeds up. As you can see, Xand's heart rate is much higher now than when he was lying down. Even at rest, it beats around 100,000 times a day.
So, you've seen how your heart beats at different rates depending on what you're doing. But how does your heart actually work? How does it get all that blood where you need it, when you need it? Well, we're going to show you.
Check this out. This is a real heart.
It's from a pig, but don't let that put you off. It's very similar to a human heart, and it's a pump with no equal.
Blood arrives in the heart all tired and out of oxygen.
The heart pumps it straight to the lungs, where it collects new oxygen.
Back at the heart, it's given a mega pump, which scoots it all around the body.
And there's no chance of it going the wrong way thanks to the heart's special valves.
And if you add up all the blood each of these beats pushes around the body, it comes to 7,200 litres a day. That's enough to fill 93 bathtubs.
We've only got one bathtub. And if you fill it with blood, where am I going to have my bath?
You need a bath. Now, to show you how it manages to do that, we're going to cut our pig's heart open.
Looking inside the heart is absolutely amazing.
The muscle here is very thick. This makes the heart really strong, and that's how it's able to pump blood right around your body.
But it couldn't do it without one important bit of the heart, the valves, and you can see them here. Their job is to make sure the blood goes in the right direction.
To see how the heart does its incredible job, we've set up our real heart, using plastic tubes as blood vessels and green water to do the job of your blood.
OK, Chris, lift your bucket up a little bit.
First, the heart fills with blood. It does this every time it beats.
Oh, look at that.
Look at it fill. OK, and squeeze now.
Xand's hands are doing what the heart does by itself thousands of times a day.
And the heart is clever because
Everything's going into that bucket and nothing's going back into Chris's bucket. The heart only pumps blood in one direction.
and that's thanks to the valves, not to Harry Styles.
But there's one question that still remains.
How powerful is the heart and how far can it squirt blood?
I filled the heart. Now, you hold that bit. I'm going to get the bucket.
Give me that. Quick, quick, quick. Get the bucket.
OK. See if you can get it.
About a foot?
Yeah, about half a metre.
OK, go. Yay!
It's not bad, but I think we can go further. Let's refill the heart.
OK, quick. Fill it up again.
But Xand's squeeze is not nearly as strong as a heartbeat.
Just aim it all in the bucket. Ready?
OK, 3, 2, 1.
Xand gets quite a lot beyond the bucket.
We just didn't get any in the bucket, but I still think that's pretty impressive. About 2.5 metres.
2.5 metres is pretty good, but a live heart actually beats powerfully enough to squirt blood more than 10 metres.
10 metres? That's more powerful than my best water pistol. Luckily, Xand's not 10 metres away.
Your body is amazing, but sometimes it needs fixing.
All over the UK, there are special teams of professionals trained to tackle medical mysteries.
The heart is the most important muscle in the body.
Between beats, it relaxes and fills with blood, like I've filled this tennis ball with water. And then when it contracts, it squeezes the blood out of it, forcing blood around your body. Now, just like squeezing the tennis ball, your heart pumping is hard work. And so to do exercise without getting out of breath, your heart has to be really strong.
But not everyone has a tip-top heart. Every year, around 4,600 babies are born with a heart defect. This is 14-year-old Luke. He's one of those who's had heart problems since birth.
So Luke, tell me about the issues you've had with your heart.
Well, Chris, I had 4 things wrong with my heart, and one of those was a hole in my heart.
When your heart is working normally, it's incredibly powerful. Blood flows through its 4 chambers and is then pumped to every part of your body. But when you have a hole in the heart, there's a little opening between 2 of the chambers. This means blood doesn't flow as well as it should, and so less oxygen gets pumped around the body.
What was the effect it had on your life?
I was lacking in energy. Whilst I grew up, my friends got faster and stronger. I was staying the same, possibly getting weaker.
2 years ago, Luke had major heart surgery, which allowed him to do more exercise.
Made me fitter and stronger, so I've been able to get out there, do more things, and just enjoy myself.
And now Luke is helping others by participating in research into how much exercise is safe for children with heart conditions.
Dr. Guido Pieles is running the research at Bristol University.
Today, Luke is going to do some exercise under the close supervision of Dr. Guido and his colleague Craig. This is the first time children's hearts have been monitored like this while they're exercising.
Here we're looking right into Luke's heart. And then we see Luke's heart muscle, because after all, the heart is a muscle. Okay. And we can see this muscle contracting, relaxing at around 80 beats per minute.
Luke also wears a mask so Dr. Guido and his team can measure the amount of oxygen he uses.
Feeling comfortable?
Yep.
Good.
Okay, so we've got a heart scanner, so we can take pictures of the heart. We've got the electrical trace of the heart, so we can look at the rhythm. And then we've got the oxygen mask on, so we can see how fit Luke is. Are you sweating yet? A little bit. Faint drops of sweat. So your heart rate's now up at 115, so it's gone up quite a bit.
Monitoring Luke's heart allows Dr. Guido to see how well it's coping whilst exercising.
There we've got Luke's heart again, and we can see that Luke's heart is contracting faster. Working much harder, but it's working well.
As you can see, the ultrasound image on the left shows Luke's heart beating faster when he's exercising compared to the one on the right when he wasn't.
And would you say he's safe to continue doing the kind of exercise he loves to do?
Yes, because after all, exercise is good for our heart. Keeps us healthy, makes us live longer.
If you have a heart condition, always check with your doctor before exercising.
Although Dr. Guido's research is only in its early stages, he's hoping to come up with some recommendations which will allow children with heart conditions to exercise safely like Luke.
Chris, can I trouble you for a favour? I need to borrow something of yours for an experiment. Is that okay?
Yeah, that's fine, whatever.
Hang on, trouble me for what? Some of your blood? You've got 8 pints of it.
Absolutely not. I'm using mine at the moment.
Yeah, but this is a once-in-a-lifetime chance to get it on telly.
Ooh, this does sound good, actually.
Great. Now remember, we can only do this because we're doctors.
Now, you might think I'm being brave with this needle, but you've got to remember that needles don't hurt unless you think they hurt, and I don't think it hurts. Nice work, Xand. I have to say, though, for all the vital jobs it does, like carrying oxygen around my body, it's not much to look at, is it? I mean, it's just sort of red and gloopy, right?
Wrong! It is much to look at, but only if you put it in one of these. This is a centrifuge machine.
This is my centrifuge machine. I've been looking for that.
Stop interrupting. We're trying to do an experiment. By spinning Chris's blood around at high speed, the centrifuge machine will separate the different parts that make up blood so we can see them.
And 10 minutes later... So there we go. Now this top liquid layer is called the plasma, and it carries nutrients around your body and also carries waste material that your body wants to get rid of. And underneath the plasma, you can see this red layer, and that is made up of red blood cells or erythrocytes. And these carry oxygen all around your body. And also in there are the platelets, and those are the cells that help you form blood clots. And right between these two layers, you can see a little bit of cloudiness. Those are white blood cells to fight infection.
Well, there we go, Chris. We're all done with that now.
Why are you giving me this?
I only needed to borrow it. I'm a man of my word. So you've seen what your blood is made up of, but do you know where your blood comes from? Well, we're going to show you. Gross alert coming up. Amazingly, your blood comes from your bones.
If you thought your bones were just solid, hard, white things that kept you standing up, then think again, because there's more to bones than that.
Now, to demonstrate this, I've got a pig's femur. That's the big bone that you've got in your thigh. And we're going to open this one up to see how bones make blood.
The femur is one of the strongest bones in the body, so we're going to need some very specialist kit to cut it open.
Exactly.
Right, Xand. Or we could use a medical femur saw. It's the only thing that doctors ever use to cut bones.
OK, we'll do it your way.
It's time to saw open some bone.
Chris, the saw.
Get ready, because this is going to be a bit messy.
This is the inside of a pig's femur. And right here, this squishy stuff is red bone marrow.
Now, it's the red bone marrow that makes all your blood cells. In fact, every single day, your bone marrow makes 500 billion blood cells.
Busy. Now, the inside of your bones looks like this. It's pink with a lot of red marrow. But as you get older, your marrow starts to turn yellow. Chris, the yellow bone marrow.
Coming right up. This is the inside of an adult cow's leg bone.
This yellow bone marrow is a much lighter colour. It's very soft and squidgy, and that's because it's mostly fat cells. This is what your mum and dad's bone marrow looks like.
And that's because your body needs more blood when it's growing a lot. But as you get older and you don't have so much growing to do, some of the red marrow, which makes blood, turns to yellow marrow, which is basically a fat stool.
So you have more red marrow than a grown-up.
But how does blood get from inside the bones to flowing around your body? Well, we're going to show you.
Come and have a good look at this. Right there, between that bit of bone marrow and the hard bit of bone, is a blood vessel.
So that's coming right inside your bones to pick up all that nice new blood being made by the marrow every single day. How cool is that?
So we've shown you that inside, your bones are amazing blood-making factories, and veins come right inside the bones to pick up that blood.
And we've seen that blood is made up of different things, all of which have different jobs in your body.
You know, Chris, I did have a sense that that chainsaw was a bit over the top.
Did you, Xand?
I could feel it in my bones.
It's not just emergency teams in hospitals that are ready to help you.
I know! There are medical crews all over the country on standby 24/7.
We're on call with the West Midlands Ambulance Service, showing you what it's really like on the front line saving lives.
On call with me is paramedic Jan Van.
This is a rapid response car, and it's one of a fleet of vehicles that respond to up to 3,000 emergency calls every day. Time to find out what it's like to be first on the scene of a medical emergency.
And a new case is just in.
All the information we've got at the moment is that somebody has fainted. So that could be an infection, it could be heart, it could be brain, it could be loads of different things. We don't know their age, we don't know if they're a man or a woman, so we just have to get there quickly as possible, see if we can sort them out.
Within minutes, we arrive at our destination.
Hello, sir. Do you remember what happened this morning?
I just went dizzy. I don't remember anything else.
82-year-old Alan was walking home from the shops when two workmen saw him fall over in the street.
But we were just working there. My mate said he's just hit the floor. He's hit his head there.
Okay.
So it's actually quite a cold morning, and he's lucky that these builders saw him fall down, because if he'd knocked his head and been unconscious for a long time, he could have got very cold, and you end up with many problems: a head injury, hypothermia, and whatever led to the fall in the first place.
Any heart problems? Your heartbeat's going a little bit slower than it should be, so I'm going to do a quick heart tracing on you.
So what Jan's doing now is taking a tracing of his heart, and the reason for that is we don't know why he's fallen, but if it's his heart that's made him fall, before we move him, we need to make sure he's okay.
And then I'm going to give you a drug to speed your heart up, OK?
Jan's found Alan's heart rate's very slow, and that's why he's collapsed. It's really good that Jan's been able to figure out the problem, and we know that he needs an ambulance and to get to hospital.
While Jan administers a drug called atropine to speed up Alan's heart, the ambulance arrives. Alan's slow heart rate is a real concern, and Jan has to administer more medication on the way to the hospital.
OK, sweetheart. This drug's going in now.
So Jan's giving Alan a third dose of atropine to try and get his heart rate up. It's really important your heart keeps beating strong and it keeps beating quickly enough to get blood around your body and particularly to your brain. What's amazing about Jan is all the things she's done for Alan, ECG, blood glucose, she's talking to him the whole time, she's doing while we're moving along at about 30 or 40 miles an hour.
Fortunately, we arrive at the hospital quickly because Alan takes another turn for the worse as he's wheeled in.
That was a bit hair-raising. My biggest concern happened. His heart stopped for about a minute, but it's restarted again now and it's talking again.
Alan actually got a lot more sick as we got to hospital. He's feeling much better now, but it's so good that he's here so quickly, and that's all thanks to Jan being on the scene quickly and a really, really good quick drive here. He's in the right place, and things are looking good for Alan.
During a short stay in hospital, Alan had a pacemaker fitted, and he's now happily back at home.
Ouch! Chris, give me your hand.
Why?
I'm about to use a special piece of medical equipment on you, and I can only do this because I'm a doctor.
Why do I feel nervous? Ouch! You've drawn blood! Is this really necessary?
Now don't try anything like this at home.
And I'm only tolerating it because Xand is a trained medical professional and he's using some piece of proper scientific equipment.
Now, the reason I pierced Chris's skin was to show you how blood is absolutely everywhere inside your body.
It's true that while it did hurt, the hole actually couldn't be any smaller. Blood still came out.
Our bodies are filled with 5 litres of blood, and it flows through an incredible network of tiny vessels. As you'll know, if you've ever cut yourself on paper, even the tiniest cut draws blood.
That's because blood vessels are everywhere in your body. You have about 60,000 miles of them, enough to go around the planet nearly 2.5 times. Now, Xand, wait here. Give me your hand. Now, I want you to take the end of this piece of string, start walking, and keep walking. Now, the string that Xand is holding represents the blood vessels in just one part of your body. So, do you think that all this string represents the amount of blood vessels in A, your arm, B, your hand, or C, just your fingertip? The answer is C. Amazingly, all this string is the same length as the blood vessels in just one fingertip. Your fingertip is only about 1 centimetre long, but the blood vessels inside it measure 1,000 metres. So that's how long this string is, and I suppose by now, how far away Xand is.
Chris? Chris?
Suppose I better get him back.
So, there are thousands of blood vessels in your body carrying blood to and from the heart to keep everything working. And you have 2 types, arteries and veins.
So take a look at this. It's a device that doctors use for spotting veins, and it has a special infrared light. Chris, meet my veins.
Look at that. Cool, that really is good. I mean, you can see Xand's veins in all their glory, and the job of those veins is to carry your blood back to your heart.
Now, your other blood vessels are your arteries, and they take blood from your heart to your muscles and organs.
This is a piece of skin from a pig. It might look disgusting, but we're showing it to you because it has arteries in it, just like yours.
They're thick, and they're tough, and elastic, and they're very strong. Now, next to them are the veins, but they're much harder to see, they're much smaller, and they're much floppier.
Now, the reason the arteries are so strong is because blood is pushed out from the heart at a very high pressure. But the whole system relies on blood vessels being nice and clear. Like roads, they work better when they're not blocked with traffic.
And to show you what happens when arteries are blocked, I've enlisted the help of some of my friends. Chris, meet John and Anita.
They're wooden cutouts.
They look a lot like John and Anita. Anyway, they both have tubes running all over their bodies, and those represent arteries. Now, the arteries on Anita are lovely and clear.
With John, though, there are little blockages all over the place. It doesn't look like a big deal, but we're going to try and show you how much difference this makes in an artery race. In 30 seconds, we're going to see how much of our fake blood, in my case blue, in Zand's case green, we can pump through the blood vessels to John and Anita's organs. Basically, we're going to be their hearts.
Start the clock.
Oh, mine's really difficult. John's arteries are so blocked that no blood is getting to his muscles or his organs. I'm having to put in loads of pressure, and this is like John having high blood pressure, isn't it?
On the other hand, Anita is extremely easy. Chris, Anita's doing fine, but John's in real trouble.
John's hemorrhaging, and I'm hardly getting anything through to the bucket.
You've got to keep pumping or he's going to die.
John is not doing well.
Time's up. Terrible.
And no blood is getting to his organs. Well, Zand, I did all I could, but it just goes to show how serious a blockage in an artery can be. It's lucky John is only a cutout.
If you want to have nice, clear arteries like Anita, you've got to exercise, eat properly, and lead a healthy lifestyle. Now, Chris, I've got a ball of string that represents all the blood vessels in your entire body. It's 60,000 miles long. Tie the end to your finger.
Zand, not falling for that trick. That is an enormous ball of string.
Ouch. Your body can need mending in all sorts of ways, and we're going to meet some special teams that are trained to fix you.
Today's fix is all about blood.
Some people are missing proteins in their blood that make it clot, which can make them bleed for longer. If they get a knock, they can bruise easily and can bleed inside joints too, where it can be very painful.
Conditions like this, where the blood doesn't clot as easily, are called haemophilia, and with the right medication, they can be treated.
Meet brothers Ben, Zach and Jake. They all have haemophilia, which is managed by injections of medicine. They have to come to the hospital every 3 months for a checkup with a team that are experts in haemophilia.
Morning.
What can you tell me about haemophilia?
That if you injure yourself seriously, then it could lead to a big bleed.
And what happens if you get just a normal cut or a scratch?
I just go and clean it and then carry on playing.
And the medicine that you've injected keeps working in your body?
Yeah.
The injected medicine allows Jake's blood to clot properly and heal any cuts or bruises. This is Dr Granger, and he's giving the boys their checkup today.
Normal knobbly knees, no swelling on that.
So they look like the normal shins of a 10-year-old boy, don't they?
It's what I call healthy, active boy bruises.
Yeah.
If he wasn't on his regular treatment, we would see very large sort of tennis ball size bruises, which would often have sort of hard lumps in them. And it'd be a lot more black and blue.
Now this isn't Jake, and it might look a bit extreme, but even a small bruise can become a very big problem if the blood under the skin isn't stopped by medication. So the routine checkup is over, and it's back to school for the brothers. No pictures! Once you're 11, the clinic teach you to inject the medicine yourself. Meet Mohammed.
Have you ever had a big cut?
Yeah.
I can see a very slight scar there on your forehead.
There is.
There.
I was playing outside with my cousins, and then I went and fell on these rocks, and then I smashed my head, and when I went inside, I was panicking because I never knew what to do.
So when Mohammed gets big cuts, he needs extra treatment. He needs more of his clotting factor, more of this special protein.
Mohammed is going to show me how he injects his medicine.
I mean, this is like you being your own doctor, nurse, and TV star all at once, isn't it?
Yeah.
All right, doctor, carry on. So now you described this like a plane coming into land.
Yeah.
And it does actually, these needles look a little bit like planes, don't they, with their wings?
Now I have to just take off the elastic, Now let me just flush all this in.
As the medicine goes into the vein, it mixes with the blood to help it clot, which means he'll get a scab if he cuts himself, which is what the doctors want.
So it's amazing watching Mohammed do this because I really want to help. Do you know what I mean, Mohammed? I really want to get involved and be like, no, because this is what I'd normally do. So it's lovely to have a patient just do it to themselves.
We do teach the boys to do their injections when they're 10 and 11, so that Mohammed can now go off and go on school holidays and have trips out without mum worrying whether or not he's going to have a bleed whilst he's out and about.
Yeah. For Jake, Zach, Ben and Mohammed, their blood doesn't clot as easily. But the treatment and training they get from the team here helps their bodies fix themselves. I mean, in the case of Mohammed, he's not just getting treatment, he's learning to treat himself. Is Mohammed going to put me out of a job?
This is a leech, and it's a type of worm. Whereas we only have one brain, a leech has 32. And while we have 32 teeth, a leech has 125. Their main diet is blood. And in fact, right now, I'm providing lunch for this one. Whilst it's on my arm, it's going to eat 5 times its own body weight in my blood.
That's the equivalent of me eating a small cow. Hooves and horns and everything. It's not just greedy, it's disgusting.
But these wrigglers can actually save human lives, all by sucking our blood. To get drinking, this leech has bitten me, and now its saliva is working its way into my veins, releasing a chemical which will thin my blood, preventing it from clotting. And it's this ability to get our blood flowing that surgeons use in modern medicine. So let's say you chop off the end of your finger.
A surgeon can attach the finger, but if blood clots have formed inside the bit of dead finger, new blood can't get in and it will fall off. What doctors can now do is attach a leech to the tip of the finger, and the same chemicals that allow my blood to flow into the leech on my arm dissolve the clots and allow fresh blood to enter the reattached finger.
There's no fancy machine or drug that can do this job as successfully as a leech. And with such an important medical role, leeches are bred on a massive scale. So while this one has a good feed on me, let's go and meet some more. This is Carl Peters Bond. He's a leech breeding king and is currently housing 30,000 of these wrigglers.
How do they breed?
Well, the leeches are a male and female, so they can fertilise themselves. Sort of boys on one section, girls on the other, and then they sort of breed together.
So when 2 leeches mate, they both get pregnant, which is pretty extraordinary.
And wait till you meet their babies. This is a leech nest.
When the leeches lay their eggs, it looks just like white foam, and then it settles down to a sort of a sponge.
So this is made by the leeches, and you can just see the clear space at the top, and then the leeches have settled to the bottom. I'm just going to cut the lid off. It is full of wriggling leeches. This is like the world's worst Easter egg, isn't it?
Yeah.
That's so fascinating, I'm completely distracted from how disgusting it is. And I'm completely distracted with the fact I've still got this enormous leech feeding off my arm. What's going to happen when he's full?
Well, it's just going to drop off, and then the hole it makes will just keep oozing blood for 10 hours.
10 hours?
Great, no one told me that. That would have been nice to know.
Well, after an hour and a half on my arm, it's finally full. And you can see how it's got the blood in my arm flowing.
This is the point. If you've cut your finger off, if the surgeons reattach the finger, it's the chemicals that are now making me bleed that allow new blood vessels and new blood to flow into the reattached finger. They may be greedy, they may be frankly disgusting, but it is that means they are the most amazing healers.
And you can see how much it's grown. It really is 5 times bigger.
I got quite attached to that. Literally. This is blood. It's not human blood, but it's almost exactly the same.
Now, without blood, you'd be dead. That's because your organs need blood every second of the day to keep them working.
So if someone's had an accident, the most important thing to do is stop the bleeding.
Blood isn't just a liquid, it's actually full of red blood cells, and your body makes 2 million new red blood cells every second.
And all these blood cells have a really important job. They carry oxygen from your lungs to all the cells in your body.
When you breathe in air, it goes straight to your lungs and travels through little sacs called alveoli, and it's their job to transfer all the oxygen to your blood.
When it goes into the lungs, it's this very dark, almost black reddish colour. When it leaves the lungs, it changes colour and becomes a very bright red.
Look at this vein in my hand. It looks bluish because it's full of dark-coloured blood that hasn't been to the lungs yet.
I can show you the direction of flow in these veins. If I squeeze the blood out of this one, you see I've made it disappear, and then you can watch it refill from this end.
And now it's on its way to get oxygen from the lungs, where it will change colour.
Nice, isn't it? I can do exactly the same thing. And you notice, the other thing you see is how quickly it refills. So if you imagine the blood just
Feels
pumping
like that,
into that.
doesn't it?
So a red blood cell starting there, be back in my lungs really quickly.
To show you what happens when your blood visits your lungs, we've got a piece of really high-tech equipment.
So we're going to use this blender.
That's my blender.
We're going to use Chris's blender to whisk oxygen into the blood. Let's see what happens.
This blood has started to form clots, so it's thick and lumpy because it's outside the body.
That's what happens to your blood when you get a cut. It reacts with the air to form a clot which glues the wound together, eventually becoming a scab.
Right, now let's make a blood shake.
By swirling it around quickly, the blender is putting oxygen into the blood.
This is what happens when you take a deep breath. The oxygen is put directly into the blood and it makes it go a bright red colour.
That's great. It looks like a blood smoothie.
There's no such thing as a blood smoothie. It looks like a strawberry smoothie.
Well, it's still your blender.
Yeah, thanks for that. So we've shown you the way that blood goes from dark red with no oxygen in it to bright red and oxygenated.
And that's what's happening in your body right now. All the new red blood cells are collecting oxygen from your lungs as you breathe and delivering it to every cell in your body.
Ligaments are attached to your bones and they're strong and stretchy, but if they're stretched too far, they can tear. This is called a sprain. Ligaments tell your blood vessels they need help urgently because blood contains healing white blood cells.
So it sends blood gushing to the sprain. The area swells up, protecting your vulnerable joint from moving. It gets hot too, so bacteria don't want to live there.
But if it swells for too long, then scar tissue can build up. The only way to stop that is to keep it cool.
Back inside, white blood cells get rid of the damage and new ligament cells arrive.
After a few weeks, the ligaments get stronger, so you're back on your feet.
Watch out!
Oh.